Yes, welcome back to my channel. I will continue about my video after part 1. This is about mechanics, mathematics, advanced level, paper 4, mechanics 1, or we also say this is M1. Yes, I already solved problem until number 5 and then we will continue to number 6. But before we continuing the problem solving, don't forget to subscribe my YouTube channel on physics course by me Widodo Waluyo from Indonesia. Okay, let me start about number 6. A particle P move in a straight line passing through a point O at the time Ts, the velocity of p v meter second minus 1 is given by v qt plus rt square. Where q and r are constants, the particle has velocity of 4 meter second minus 1 when t equal 1 and when t equal 2. Question 1. So that when t 0.5, the acceleration of p is 4 meter second minus 1. Okay, how to solve this? Actually, uh, we use v here. V equals to q 4. Oh, sorry. Oh, wait. This is v when v 4. This is when q t is 1, yeah, plus r t square 1 1. So we get 4 equals to q plus r. 4 equals to q plus r. So if in the time 2 also we have 4 also, q times with 2 plus r 2 times 2, so we get 4 equals to q plus, oops, sorry, this is, I wrong this is r, yeah, and this is equal to 4r. So if we simplify this question, we divided by 2 equals with q plus 2r. So in order this question, yeah, we have 4 equals to q plus r, and then we have 2 equals q plus 2r. If we eliminate, yeah, that will become 4 minus 2 equals 2, then q minus q equals to 0, then r minus 2r equals to minus r. So we get the r equals to minus 2, right? Yeah. How about Q? That if we substitute R minus 2, yeah, and come Q equals to 4 plus 2 equal 6. Okay, finally we get the equation of V in terms of T. This is about Q is 6, T plus R is minus 2, it's become minus 2 T square, T times T. Let's say that, yeah, because can I cannot to write the square one. Okay, we get this. Yeah, this is the formula for uh, equation of V. Yeah. Okay. Now the question is when the t 0.5, the acceleration of p is 4. Let we sorry, here acceleration is, this is about differential v dv dt, or a equals 6 minus 2 times 2 is 4, yeah, times t the power 2 minus 1, and that become a equals to 6 minus 40. So a when t equal to 0.5, we substitute here 6 minus 4 times 0.5. Yes, a equals 2. 6 minus 2, 4 meter second square. That's the answer is. So the answer is same with the proven. Yes. Okay. So continue question II. Find the values of t when p instantaneous rest. Okay, when rest v become 0. So we have about equation v equals to, let's say first, 60 minus 2t square. So if v becomes 0, it's mean 6t minus 2t times t. So 2t equals 6. 2t equal 6. So time when p is at instantaneous rest, t on 6 divided by 2, 3 second. Yes, that's the answer is. Okay, we'll continue to the next number. If you see the big one, yes, big one, yes, in 3 seconds, yeah. So question I. The particle is at O when t equals to 3. Find the distance p from O when t equals to 0. Wow. We will find about the distance by uh, integration of v. Yes, s or distance. Distance is integrate of velocity equation. Then distance equals to, yes, we see the v is, we'll copy this first, come here. Oh, I can integrate of 6t minus 2t, sorry, dt. So distance equals, oh, this is between uh, 0 until 3 seconds, yeah, 0, sorry, 0 to 3. Then integrate of 60 equals to 3t square minus 2 divided 3, 3 to the power of 3. Oh, then it's um, time t1 equals to 0 and time 2 equals to 3 seconds. So if we substitute this t1 and t2, it's become, the distance is 3 times t squares, this equals to 27 minus 2 divided by 3 of 3 times 3 times 3 equals to 27 minus 0. Yes, because if the t equals to 0, we substitute t into this equation, it will become 0. So the distance is 27 divided 3 equals to 9. 9 times 2 equals to 18. So 27 minus 18 equals to 27 minus 18 equals to 9. Yes, the answer is 9 meter. Will be this the big one. If you want to see, the answer is yes, 9 meter. Whoa, question 7. I think this is the final question, yeah, final number. So the diagram, yeah. I saw the diagram, a particle A of mass 0.8 kilograms lies on the plane inclined and of 30 degree to the horizontal, and particle B of mass 1.2 kilograms lies on the plane inclined at the angle 60 degree to the horizontal. The particles are connected by like an inextensible string which has a small pulley P fixed at the top on the planes. The part EP and BP of the string are parallel to lines of greatest slope of respective planes. Yeah. The particles are released from rest with both particles of the string taught. Okay. Question 1. Given that both planes are smooth, find the acceleration of A and tension in the string. The point is 6. Okay. I will use the Newton's second law about total force equals to ma. Total force equals to mass times acceleration, and sorry, I will throw it to come to down. Total force, oh sorry, total force is about the mg sin and mg sin also for the particle A and B. Ma g sine 30 plus negative, not plus, yeah, 1.2. Let's say we directly 0.8 g sine 30 minus 1.2 g sine 60 equals to total mass 0.8 plus 1.2 A. So if we use the acceleration g is 10, we can multiplying by 0.8 with g equals to 10, then sine 30 a half, so we get 8 times a half. This is here is 4, oops, minus 1.2 times g is around 12. So if we multiplying with the sine 6t, 6 times with 12 is 10.39 equals to 2a. That we get a, it's around, we calculate 2 divided 639 to 639, okay, 0.31. The acceleration is 0.31. Actually, if we use this equation, we get the negative sign, yeah, is the direction of the move of the system is clockwise. Now I will change the position of this equation. Here is come to here, sorry, and then here is -4, yes, This is we get a 0.31. This is on the clockwise. Yeah. Okay, we get about the acceleration, and then how about the tension? Yeah. Okay. The tension actually we still use the total force equals to ma. If we see on the mass block B, we get the total force in B. It's equals to mb uh, g sin theta. We already get it. That is about 10.39 minus tension group equals to mass of B times A, and then A we get around 0.31. Yeah, so we can find T equals to, we use calculator first. Yeah, 1.2 times 0.31, it becomes 0.372, and 10 minus that number, yes, it become 10.02 Newton. Yes, we get the tension rule finally about rope of that system. Let me the big one. Yes, this the answer one, and this the answer one too. Okay, continue to question II. It is given instead the both blades are draft with the same coefficient of friction U for both particle. Find the value for which system is limiting equilibrium. Wow, find the value. Okay, if the system in equilibrium, yeah, if in limiting equilibrium, its mean total force equal to 0. So if we see the frictional force on this system, we see that come from mass B, yeah, 1.2 g sine 6, and then minus frictional force, yeah, let's say U with normal contact force, yeah, times normal contact force is mg cos 60 also. Yes, this is the force acting on the mass B. Yeah, on the mass B. Let we break it this. Yeah, and also minus mg on the particle A 0.8 g sine 30 minus frictional force acting on the mass, uh, the left one, yeah, minus a 0.8 g. We need to calculate the system with uh, mg 0.8 g cos 30. Yes, so this is equals to 0. So if we want to find this question about u, so we get here g, it will be neglected or just cancel it, yeah. And then we see this uh, about 1.2 sine 60, it's around it's around 7 2 minus u cos 60, it's around, sorry, I think it's for 7.2 here is, that we repeat again about this calculation. 60 sine and times with 1.2, no, it's wrong. This is about 1.0, 1.05 here, and then u times with cos theta is 0.6 equals 0.4 minus u that we see cos 30 times 0.8 is equal, this is equal 0.69. Okay, and then if we see about u, we have 0.09 u equals to oh, 0. Let me check first. I think this is any wrong here. 0. Zero point 0.2 g sin 60 minus u 0.2 g cos, okay, cos u with sin 60, what was sin 60, 60 sine 0, yeah, times with s 0.1, 0.4 there. Oh yes, yes. Correct, correct. This is still this 1 minus 1.04 minus 0.4. This is equals to 0.64. So we get divided with 0.09 and we get 7.1. The U is 7.11 and 11. Yes, yeah, we get this answer about the frictional force. Yeah, if limiting in equilibrium, we get the mu is around 7.11. Okay. Thanks. This is the final number. This is the last number. So thank you very much for your watching my video. Don't forget to subscribe. Uh, my channel is physics slash course. Don't forget to like, comment, and maybe push the button notification. Thanks. Thanks. Bye bye. See you on the next video. Don't forget to see some video from me. Thank you for the subscribe. Thanks very much.